Hi everyone, this lesson is for geometry students. This is chapter 7, lesson on special quadrilaterals and proofs. This is day 4 of our chapter 7. So let's get started. Basically, our learning targets are, we're going to talk about two-column proofs and also talk about properties of parallelograms, kites, quadrilaterals, etc. If you look at this chart, I really like this chart because it talks about quadrilaterals being four-sided shapes, of course, and then the different types of quadrilaterals that we have, which are kites, trapezoids, and parallelograms. But within those, we have for trapezoids, we also have isosceles trapezoids. We also have for parallelograms, the three special quadrilaterals or special parallelograms, which are rhombuses, squares, and rectangles. So getting started, we already spoke about the different qualities, characteristics of a parallelogram. Both pairs of opposite sides are parallel. So we did talk about that previously, where this side is parallel to this side here parallel to that opposite side. Both pairs of opposite sides are congruent, which also means these are congruent on the other sides. Both pairs of opposite angles are congruent, so whatever that angle is, it's equal to this angle here. And then whatever angle this is, it's equal to this side, that angle as well. The diagonals bisect each other. They're not the same length necessarily, but they do bisect each other, meaning they get cut in half. So this side, that part of the diagonal is equal to that one, and this part is equal to that part. And then the last characteristic of a parallelogram is that one pair of opposite sides can be both congruent and parallel. So option, I could have this parallelogram would be parallel on this side, but also congruent. And then you don't know any other information about the other side. The other option would be if this side is parallel to this side and this is congruent to that side. Special parallelograms, rectangular, things about rectangles that are important and characteristics. Number one, of course, both pairs of opposite sides are congruent, opposite angles are congruent. A rectangle has all of the characteristics that a parallelogram has already. But in addition to that, it does have 4 right angles. And the other pretty nifty thing about a rectangle is that the diagonals, while yes, of course, they do bisect each other because that's a characteristic of a parallelogram, but they also are the same length so that the diagonals are congruent. Both of them are equal, and that's not true in all cases, but those are the 2 extra characteristics that, in addition to the 5 characteristics that a parallelogram has, a rectangle has these 2 additional ones. Now, a rhombus also has additional characteristics beyond the 5 that it has. So a rhombus, number 1, does have diagonals that bisect each other. Yes, but not, unlike the rectangle, they are not congruent. What they are, though, are perpendicular. So number 1, additional characteristics is that the diagonals also are perpendicular. Additionally, in a rhombus, we have 4 congruent sides. So we have 4 congruent sides. And also, if I just have 2 consecutive sides congruent, that would make it a rhombus as well. Additionally, the diagonals of a rhombus bisect the opposite angles, so that not only are the opposite angles congruent, because we know that from it being a parallelogram, but we also know that in a rhombus, the diagonals bisect. That means they cut in half those angles. So let's say this was 100 degrees, each one of those would be 50. And if this was 100 degrees and each one of those were 50, then this angle down here would have to be supplementary, of course, and that would be 80. So these would each be 40 because, again, the diagonals bisect the angles. So that's an additional characteristics. So the diagonals bisect the angles, opposite angles. All right, so that's that. And for a square, now a square is super powerful because not only does a square have all the characteristics, again, of a parallelogram, but additionally, it has all the characteristics of a rectangle and all of the characteristics of a rhombus. So a square has 4 right angles, just like a rectangle. It does, just like a rectangle, have congruent diagonals. Okay, a rhombus doesn't have that. But what a square does have are perpendicular diagonals, like a rhombus does. So the diagonals are perpendicular. And additionally, a square has 4 congruent sides as well. So 4 congruent sides. And lastly, the diagonals, these diagonals bisect the angle. So of course, it being a 45, it would have to be a 45 degree once you bisected it. So the diagonals bisect the opposite angles. And so that's, it has all of the characteristics of a rectangle and all of the characteristics of a rhombus, and that's what a square is. Now, a kite is definitely a little bit different, okay? A kite is also a parallelogram, but it's not it's a quadrilateral, but not necessarily one of our special parallelograms. So this is more of not a parallelogram, actually. That's inaccurate. Let me erase that. It's a quadrilateral and not a parallelogram. So quadrilaterals, because a parallelogram has all those 5 characteristics, and this doesn't have any of those. So that's not necessarily true. So a kite, number 1, does have 2 congruent sides. It does have diagonals that are perpendicular, but the diagonals do not bisect each other. Only this diagonal bisects this one. See how they're equal on both sides here, but not on the other. So that might be 5, that might be 10, but these could both be, let's say, 6. So we do have 2 congruent sides on the outside, and then another 2 congruent sides down below. My diagonals are perpendicular. And lastly, for a kite, it just has 4 congruent sides, and that's it. Okay. So one of the things that we're going to do is to try to make a 2-column proof to prove that the 2 triangles are congruent. Now this, if it looks like, because we have both sides, both pairs of opposite sides are parallelogram, it looks like we are given that this 4-sided shape, quadrilateral, A, B, C, D, is a parallelogram. Okay, so for me to prove that the 2 triangles are congruent, that's what I need to write. I'm going to prove that the 2 triangles, I'm not going to write that out, the 2 triangles. You're going to write out the triangles that you want to be congruent. So I would say triangle, ABD. So I'm going to say triangle ABD is congruent to triangle, we're going to go with CDB. Okay, so given that we're trying to make those congruent, we need statements and also reasons. And so we have our statements and we have our reasons. And I'm going to draw this little line here, bring this down, and here we go. So the first thing you do, number 1, is you write about what's the given. The given is that quadrilateral ABCD is a parallelogram. I'm going to abbreviate a little bit. And number 1 reason is because that was given. All right, and so in order to get from here to where we want let's say, I'm not sure what the name is, but we're going to call it the 2 triangles congruent. In order for me to get this Okay, let's see. That's not really taking all of that. Let me just copy that. In order for me to get that to be congruent, those two triangles to be congruent, okay? In order for two triangles to be congruent, they need to be congruent by side, angle, side, 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 angle, side, angle, hypotenuse, leg, which isn't going to be this one, or angle, angle, side. So one of those needs to be our, our reason for the two triangles to be congruent. Now, our second step is why do you think they told us that this was a parallelogram? Well, if this is a parallelogram, number one, if AB is parallel to CD, then that makes ABD, this angle, congruent to this angle because those are alternate interior angles are congruent. So I'm going to say angle ABD is congruent to angle CDB because alternate interior angles are congruent, okay? And additionally, because AD is parallel to BC, that makes this angle here congruent to this angle here. Okay, so number three, actually I can use the same reason because the angles are also alternate interior angles. So I'm going to say angle ADB is congruent to angle CBD, also because of alternate interior angles congruent. Now, we also know that we have a line segment BD that's in between both of these triangles, which is going to be the same length in this triangle as it is going to be in that triangle. So what that means is that that angle is that length of side, that side length is going to be congruent to itself. So I'm going to say line segment BD is congruent to line segment BD itself by what we call the reflexive property, because it's like a reflection. It's in both of the triangles. So we call that the hold on a second, I guess spell. Reflexive property of congruence. All right, so now we know that this angle is congruent to this angle here. That blue angle is congruent to this blue angle. And we have the side in between the two angles congruent. So the reason why triangle ABD is congruent to triangle CDB is going to be then by angle, side, angle. And then we're done. So again, this is a two-column proof again to prove that the two triangles are congruent. So we are going to say given, this is a quadrilateral one, but it's not a special quadrilateral. We're going to say this is given quadrilateral ABDC. Oops. Quadrilateral A, B, D, and then C. So that's our given quadrilateral. And and also within the diagram, you are given all of this other stuff. Okay, and so we are going to note that when we decide to prove what we're trying to prove. Now, what we're trying to prove is that these two triangles are congruent, which by right now, in order to prove that the two triangles are congruent, so I want ABD is congruent to triangle ACD. For me to prove that this right triangle here is congruent to this triangle on the left, I have to have, again, one of those things. I need side, 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 side angle, side, hypotenuse, leg. It's not going to be hypotenuse, leg because none of these are right angles. Let's see. So I'm going to say statements and reasons. Okay. And so we're going to go like this. And so again, number one for my given is given diagram, which is quadrilateral ABDC, and that's given. Now, for me to prove that those two triangles are congruent, that's going to be my last statement. I'm not sure what number that is. I'm just going to draw it down here. ABD is congruent to triangle ACD. For me to prove that, it's going to be one of my 5 reasons, okay, that two triangles are congruent. What I like is, and I actually have several options. What we do know is that AD is congruent to itself. So I'm going to write that first. So we know that AD, which is in that line segment, is in both of the triangles, is congruent to itself. And so therefore, because it's congruent to itself, it's congruent by the reflexive property of congruence. Okay, so now you just have to decide how you want to do it. There's multiple ways to do that. I could say that angle C is congruent to angle B. That works. And also this angle here, ADC, is congruent to ADB. And therefore, the two triangles would be congruent by angle, angle, side. Or I could say that the two triangles are congruent by angle, side, angle. So it's just a matter of what do you want it to say. You cannot say the two triangles are congruent by angle, angle, angle. You must have at least one side that's congruent in both of the triangles. So we do have a side, AD is congruent to itself, and I'm just going to choose. So I've got, for my third step, I'm going to say angle C is congruent to angle B. And the reason for that, number 3, is given in the given, I'm going to say diagram, because that was given in the beginning. And I'm also going to say for step number 4 that, and I can't say angle D equals angle D. You don't say that. You have to say, because you're not sure, are you talking about this angle D, or the big angle D? You don't know which one you're talking about. So you have to be very specific in that. So you're going to say angle ADC. So angle ADC is congruent to angle ADB. And the reason also is given the diagram, which we were given in the very beginning. So for our 5th step, now that I know that this angle is congruent to this angle here is congruent to this angle, and I have this side, which is in both of the triangles, congruent to itself. These two triangles, I've chosen to say that they're congruent by angle, angle, and side. Now, like I said, you could have very easily taken out this step right here, this one, and instead of that one, you would have said angle DAC is congruent to angle DAB, and you could have said also given triangle, but that would have been the reason, given diagram, but that one would have also worked. And had you used this angle up here, then the two triangles would have been congruent, not by angle, angle, side, but by angle, side, angle. So you definitely could have done that as well. Just another option for you to choose. For this problem here, it says the figure below is a parallelogram. So again, we know both sides, opposite sides are congruent, opposite sides are parallel. Additionally, if opposite sides are parallel, what that means is that the angles, you have alternate interior angles, but also you know that the angles are what we call supplementary. And what that means is that this angle here plus this angle here have to equal 180 degrees. So therefore, this angle Z would be 115 degrees. Now, that being said, we know that those are equal to each other. We also know, because it is a parallelogram, that opposite angles are congruent. So if that's 65, this angle also is 65. And if this angle here is 115, then its opposite angle is also 115 degrees. Also, one last thing is that this being a straight line, that adds up to be 180 as well, 180, which means that 115 plus x degrees also equals 180. And so keeping in mind, you can subtract, of course, and get x equal to 65. Or you can say, hey, oh, wait, these angles here, because these lines are parallel, right? They're alternate interior angles. All right. For this problem here, the figure below is a parallelogram. You are to solve for x, y, and z. So here's x, here's y, and here's z. So we know because this shape, the outlining shape, that's a diagonal. We know the outlining shape is a parallelogram. It means that x must equal 56 because opposite angles are congruent in a parallelogram. Additionally, you know that these two angles, this one here and this one here, are supplementary, which means that 56 plus some angle has to equal 180 degrees. And that angle, this whole angle, has to be 124 degrees. So therefore, if part of this being 85, and this part here, y, 85 plus y must equal 124. So I'm going to take 124 and subtract 85. And I get, for y, I get 39 degrees. So this value here is 39. Now, the last thing is that, again, this being this as 124, that also is 124. But keep in mind that this triangle here has to also add up to be 180 degrees. So let's take 180 and subtract 56 and subtract 39. So we've got 180 minus 56 minus 39 degrees is 85. And so we know z is 85 degrees. Now, I just want to say, I'm going to erase this stuff here for 1 minute, because if this is, in fact, a parallelogram, which it does state, we also know that these sides here are parallel, okay? And if that's the case, that would make z and 85 alternate interior angles, which basically means I didn't actually have to do all this subtraction. I could have just said, oh, 85 is equal to z because they're alternate interior angles. For this problem here, IJKH is a parallelogram. Again, alternate interior angles. Opposite angles congruent. Diagonals bisect each other. Diagonals bisect the angle if it's a rhombus or if it, however, it didn't tell me what it is other than it being a parallelogram, which means that I only know that the opposite angles are congruent, okay? Now, given this information, I know for this problem up on top that HM is 2x plus 5 and MJ is 4x minus 19. Well, if this is a parallelogram, check, then the diagonals bisect each other, which means this length is equal to this length and this length is equal to that length. So I can say 2x plus 5 equals 4x minus 19. Subtract 2x, I get 2x. I'm going to add 19 to both sides, right? And I get 2x is equal to 24, so x is equal to 12. Now, on this problem here, the second part, I'm going to erase this now. And because this part is talking about angles, not lengths. So it says that angle 2 is 25 degrees. Well, that means angle 1 is also 25 degrees. It also says that HIJ, so HIJ, this angle right here is 120. So think about it like that. Is that going to work? Hold on. I think there's a mistake. Because if that's 120, this has to be also 120. Oh, because they're not bisected. Excuse me. Because if that's 120, this angle is also 120. Which means that 120, right, 180 minus 120 is 60, which means that this angle here, this big angle right there, has to be 60 degrees. Well, 60 minus 25 is going to give me 35 degrees, which means that this angle has to be 35, and this angle also has to be 35. Obviously, this is not a rhombus because it's only a parallelogram, because if it was a rhombus, then the angles would be the same, which they're not because it's not a rhombus. So in answer to our find the measure of angle 3, you would say the measure of angle 3 is equal to 35 degrees. For this problem, your job is to make a 2-column proof that is going to prove that the two triangles are congruent. So what we have is given. So we are given the information. You can say triangle ACB. So we're given triangle ACB, larger triangle, or we can even say given the diagram. I even like that better because what we are trying to prove is that ACD, triangle ACD, is congruent to triangle BCD. So BCD. Additionally, we know, or what is given, is that segment AC is congruent to segment BC. So we see that by the diagram. We also know that angle ACD is congruent to angle BCD. And that's this angle and this angle, those are congruent, okay? So in order to prove the two triangles are congruent, we either need to say side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse, leg, which, because I know that C is congruent to itself because it is reflexive, we can prove that the two triangles are congruent by side, angle, side. So this is the one we're going to use. So you just have to write what you just did. Okay, so these are my statements. These are my reasons. And in doing that, okay, statements and reasons, you rewrite the given. So we are saying that AC is congruent to BC. We also know that angle ACD is congruent to angle BCD, and that's just given. Okay. So we already have two parts of the triangle. So now the next thing that we're going to say for this problem here is that CD, segment CD, is congruent to itself. And that's the reflexive property of congruence, okay? Number 3, we have enough information already, shortest proof ever, that triangle ACD is congruent to triangle BCD, and that's by side, angle, side. Okay. Summary of parallelograms. This just, again, has all of the parallelogram characteristics that you should review. And what we're going to do right now is do a little bit of practice, all right? So if x and y, find x and y, you see that this quadrilateral is a parallelogram, which means that both of my diagonals have been bisected. So therefore that I can say that this length here is equal to this length, and this length is equal to that length. So in order to find x and y, to find x, I can set 2x equal to x plus 9. And I additionally can set 3y minus 8 equal to y plus 12. So for this problem, I'm going to subtract x. I get x is equal to 9. For this problem, I'm going to subtract y. I get 2y minus 8 equals 12. I'm going to add 8 to both sides. I get 2y is equal to 20. Divide by 2, y is equal to 10. So we have x, we have y. For this problem here, you want to solve for x and y again, but in this case, x and y are actual angles. Also, it looks like I'm trying to solve for z. So x, we have y, and we have z. Z, what do I know here? Z is going to be the same length as this length, which is 9. There's no length here, so they're not asking me anything there. But what I do know, what I can say is that 70, let's see, 70 plus 50, right? That's 120. And I'm looking at this triangle here on the left, this triangle right here. And what I'm doing with that is this. This triangle here, at the angles add up to be 180. So if I take 120 and subtract from 180, that makes this angle 60. Vertical angles, that makes that angle 60. That makes this angle 120 and this angle 120 as well. Now, 120 plus 33 is 153, but if I take that away from 180, that makes this angle 27. Because it is a parallelogram, although it doesn't state it, it is, that means that we have alternate interior angles that are congruent, which means 27 is going to equal x, which is 27. So x equals 27 degrees. I know that 33 is going to equal y, so y is equal to 33 degrees because those are alternate interior angles. For this problem here, we have x, we have y, and we have z, okay? For z, I'm just going to solve that one pretty quick because if it is a parallelogram, we know that opposite sides of a parallelogram are congruent, so that means z has to have a length of 15. Now, x and y, I guess this should be and z. X and y are angles, so even though this angle here is 30, this angle would also be 30 degrees, but that's not helping me right now. What is going to help me is if I add 80 plus 30, right? So 80 degrees plus 30 degrees gives me 110. And if I take 110 and I subtract from 180, that makes this angle 70, which makes y 70. Now, lastly, we know that in all parallelograms, the opposite angles are congruent. So that means x has to be 80 degrees as well. So x is 80 degrees. Y is this value here. That's going to be 70 degrees. And then we know z is 15. For this problem, we're just solving for x and y. We know that opposite sides are congruent. So if opposite sides are congruent, I can say that 2x, this length here, is equal to this length here. So 2x plus 8 equals 14. We also know that this length is equal to this length because, again, opposite sides. So 3y equals 15. So y is equal to 5. So we have that value. For this one, I'm going to subtract 8 from 14. I get 6. So 2x equals 6, which means x is equal to 3. For this problem, in order to solve for x and y, what this here is showing me, these little loops here, is that these two angles are equal. So if that's 80, that's 80 as well, which also means that that's 160. That also is 160, which means that's 80 and that's 80 also. We know that this angle is going to equal this angle, alternate interior angles. If I know that this angle here is 100, if I know that this angle down here is 160 degrees, because that's 80 plus 80, right? They have to be the same. Then these two angles here are not congruent, of course, unless it's a right angle, but they're not. But they are supplementary. So I know that they add up to be this angle plus this angle has to add up to be 180. So there's the problem. Because that would make that 20 and it's already 35. Okay, so this one actually has a little bit of an issue. Let me look at y for a second. So I'm assuming then that these little lines are not congruent. So let's just look at y for a minute. If this here is congruent to this angle, then I can at least go 6y plus 5 is equal to 35. I can say 6y equals 30, and I can say y is equal to 5. So I know y is equal to 5. If this is 35, this is 35 here. And other than that, there's X is going to give me an issue because I can't find this angle, because if this is, I wonder if they're saying that that's 80 and 80. I'm going to assume that that's what they're going to say, because otherwise, if that's 80 and that's 80, then the triangle is not possible. So we're going to assume that the sum of these is 80. Like, I'm going to assume that the whole thing is 80, and that the reason why they did that is because they're congruent, which would make that 40 and that 40. So if that's the case, then that would make this, yes, 80, the sum. And then I would go 180 minus 80 is 100, right? And then 100 minus 35 would make this angle here 65 degrees, which totally would work, because then we can say 5x is equal to 65. So I can say 5x is equal to 65 degrees. And if I divide by 5, I get x equals to 13. And that would be so much better. So I'm going to have to make a note of that. For this one, this is an isosceles trapezoid, which means that my base angles are going to be congruent. Now remember, an isosceles, or a trapezoid, is a quadrilateral, which means it is four-sided. It also means that the angles, because these lines are parallel, it means that the sum of these two angles on the top and the bottom on like one side are supplementary. So if I took 180, right, and I subtracted 130, I get 50 degrees, which means that this little angle down here is 50. It means that little angle also is 50. And additionally, because it's isosceles, whatever this is has to be the same here, which is 130 degrees. So again, we have two more isosceles triangles. Notice that opposite angles are not the same because it's not a parallelogram. They're only the same if it's a parallelogram, which it is not. It's a quadrilateral, but not a parallelogram. But what you do know is that that's 70 and that's 70. And you also know that these two angles, because these lines are parallel, are supplementary, which means that's going to be 110, and then that means x is going to be 110 right here. For this problem, this is x. We don't know what that is. That's x. This has to be 2x. So this problem is a little bit more interesting in that they didn't give us actual values. They just said, hey, 2 times this angle and angle. So that means that, again, 2x plus 2x plus x plus x, all the angles in a quadrilateral have to add up to 360 degrees. So we've got 2, 4, 5, 6. We have 6x is equal to 360 degrees. If I divide both sides by 6, I'm going to get x is equal to 60 degrees. So that means this angle is 60 degrees, but because this is 2 times that angle, this angle right here is going to be 120. For this problem here, it's a little bit trickier, definitely. This length equals that length because the diagonals bisect each other. So that means that I have 2x plus 2y is equal to 18. Also, I know that's 20, but that really doesn't help me in that finding out what x and y is, because I have two unknowns. That means I have an x and a y, which I don't know what they are. I need 2 equations. And so the other equation I'm actually going to find by opposite sides of a parallelogram are congruent, which means that 2x plus 5y is going to equal 30. And so now I have a system of equations, which means that I have elimination, I have substitution, I have graphing method. I've got a lot of different options to solve for x and y. I'm just going to subtract the 2 equations, which we call elimination. I'm eliminating one of my variables. 2x minus 2x is 0. 2y minus 5y is negative 3y. And then 18 minus 30 is negative 12. And one thing that you should remember is that, see this negative sign out here? That actually is subtracting each one of the quantities in the parentheses. So definitely be careful with that. So I get y is equal to 12. And y is equal to 4. And so now I have y. All I have to do is plug it back into one of the two equations that I have. So 2x plus 2y, y is 4, equals 18. I've got 2x plus 8 equals 18. I'm going to subtract 8. I get 2x is equal to 10. X is equal to 5. And so now I have both x and y. For this problem here, M is the midpoint. Oh, if it's a midpoint, that means that it divides that segment into two equal parts. If EM is equal to, so this length here is equal to 4x minus 2, and MF is equal to 3x plus 9, I want to solve for x. Now, I know that because it's a midpoint, that the two segments have to be equal. So all I have to do is go 4x minus 2 equals 3x plus 9 and solve for x. So I'm going to bring 3x to the left, and that makes 1x. I'm going to add 2 to both sides, and I get x is equal to 9, 10, 11. So x is equal to 11. Students are going to be introduced to two-column proofs. Check. We talked about parallelograms, their properties, and also kites. And so we've completed our learning targets. You guys have homework, worksheet section 7.2.1, as well as a review worksheet. And for this review worksheet, this is review worksheet number 1 that you're going to be doing for tonight. All right. Thanks so much for watching. I definitely hope it helped, and have a great rest of your day.